Okay, so you'll get started here. Can you guys hear me?
Yeah.
So today we're going to go over variables and expressions. So let's have a problem. Say Bob has some number of dollars, and say if Joe has twice Bob's dollars with one more dollar, and let's say name Tony has thrice, actually 4 times Bob's amount minus 5. If Bob and Joe's sum combined is Tony's amount, then how much does Bob have? This kind of problem we would use variables for. So let's say Bob has X. So X is a variable which stands for any amount of money, any amount of anything really. And something like 1, which is like any number, is a constant. Because it's constant, it doesn't changes, and a variable is variable, it is in flux. So now we need to make an expression of Bob's and Joe's money to match Tony's money. So since Joe has twice Bob's money plus 1, that would be 2x plus 1 money. And then Bob's and Joe's money would be plus x again, which would simplify down to 3x plus 1. This, by the way, is an expression. It's a combination of either constants or variables in order to produce some sort of value. So if we put this in an equation for Tony's money, then if we minus 3x from each side as such, and plus 5 to each side, we would get 6 equals x. In this expression, like we had before, this is a term which is a multiplication of a variable and a constant. Like 3 is the number, or in this case, it's called the coefficient of the variable, since it shows how much of a variable that is. And this 1 is also a term, since even though it lacks of variables, but it is the constant term. So in order to evaluate expressions, we would have to find what x is, but And if we knew what x is, say x equals 4, we could substitute this back into the expression in order to find the value. So if we had this value, what would be 3x plus 1? You could just message me in chat. I'm not going to use Socratic from now on since it apparently didn't work for some people. So if we were to substitute this into 3x plus 1, we would get 3 times 4 plus 1, and that would equal 13. So now we have to go on to simplifying expressions. So if we had, say, an expression such as 3x plus 1 plus x squared plus 5x times 3x. So first, we would have to go through pandas, which we went over last time. So we have x squared here, which keeps itself since e is above everything else except parentheses. Then we have multiplication. This becomes 15x squared. Now we have to combine like terms. So a like term is one or more variables raised to the same power. So I'll talk about more than one later, but for now, a like term would be the variable raised to the same power. So these two are like terms because x is both raised to square. So we could combine these two like terms because they're essentially 1x squared plus 15x squared. So we get 3x plus 1 plus 16x squared, which would be how we would simplify this expression. Now, if we had an expression such as this one, 5x minus 3 divided by x plus 1 plus 2 over x minus 3 plus 7x. What's the simplification of this expression? Okay, so first we have to find like terms. These two share the same like term of x to the first power, and these two terms share the same in power of x to the -1, which we know is 1 over x. So we add these two, which is 12x, and these two, since this one's negative, plus 2, which is -1x, plus 3 minus 1 will be -2. Does anyone have any questions about that? Am I going too fast? I could just repeat everything if anyone needs to. Onwards, if no one has any questions. So before last class, we knew that 5, say 3 plus 7 means that 5 gets multiplied into 3 and into 7. So similarly, if we had x here, 5 plus 2x, x gets multiplied into 5 and into 2x, which creates 5x plus 2x squared. Similarly, x, if we had something like x to the 5th, 3 plus 2, we could shave an x off of both the denominator and the numerator to get x4 over 3 plus 2, since x5 over x equals x4. But it doesn't need to be x by itself either. We could do say x minus 2 times 3 over, no, I could do 3x plus 6. If we were to do the opposite of we were doing before, factoring instead of distributing, we can see that each side has a factor of 3. So we have 3x plus 2. If we were to do it the other way, you could see that 3 gets multiplied into x onto 2, showing how we could take back a common factor like x squared plus 3x. They share the factor of x. So this can become x plus 3. furthermore, if we had something like n to n plus 1 plus 7 to n plus 1, they share the, where I'm using n as a variable instead of x. You can really use any letter for a variable, just else looks like a 1 when it's lowercase, so try to avoid that. So they share a common factor, so we could just do what we did before and do n plus, and write n plus 7 here instead. If we were to pretend this would say, oh, x or whatever, we could see that nx plus 7x equals n plus 7x, which makes this more intuitive. Does anyone have any questions? I know some people just entered, so I could answer any you guys have. So by the same token of what we did before, let's say parentheses 3x plus 7 multiplied by parentheses 5x plus 9, we could distribute this. This would equal 3x 5x plus 9 plus 7 5x plus 9. Since this in itself, it would be a common factor of both of these. So we could split apart this parentheses into 2. And thus we could distribute on 3x times 5x is 15x squared plus 3x times 9 is 27x plus 7 times 5x is 35x plus 63. Now we have to combine like terms of which there is only x, so 15x squared plus 27x plus 35x is 62x, which is 63. Now an easier way to do this would be to write it something like this. Which is very similar to how you would do multiplication. So like if I were to write 30x times 59, this gets multiplied with this gets multiplied with that. So 15x squared plus 35x, this gets multiplied with that, this gets multiplied with that, plus 27x plus 63. Similarly, this times that with this times that. I did it in the opposite order that time. 3, 3, 3, this times that, and this times that. 1850, which becomes 2183. It's very similar to how you would multiply two numbers, just that you would use x and whatever coefficient instead. As a bit of a practice, why don't you guys calculate 5x plus 1 times 2x plus 3? What does this equal? Now, I can't force you guys to participate, but I would really appreciate if you guys could. If you guys don't know how to do it, I could just explain it again. Okay, so now we go on to fraction. So as I've said before, or if we had something with a common factor on both the denominator and the numerator, like 36/78, both of these are divisible by 6. So 6, 6, 13, 6. So these can be crossed out in order to simplify into 6, 13. So we could do the same as variables. X plus 2 over x squared equals x plus 2 x equals x plus 2 over x. Similarly, if we had fractions added together, say 3/4 plus 4/5, we would need to find the lowest common multiple of these two denominators, which is the lowest number such that you can multiply each denominator by an integer in order to get said lowest common multiple, which in case is 23, and 3 gets multiplied by the LCM and which is shorthand for lowest common multiple, and divided by its denominator, which is 4. So that's 20/4, 5. 4 times 4 equals 31/20. Similarly, if we had x plus 2 over x squared over 4 plus 5x minus 3 over 2x plus 1, we would need to find the lowest common multiple between these two, which in this case is its product. So we have the lowest common multiple of these two in order to add the fractions together, which is x squared plus 4 2x plus 1, and we times x plus 2 times the lowest common multiple and its own divisor, which is this. And we do the same to 5x minus 3, which this simplifies down to x squared plus 4. Now, if we did this, we cross these two out, and we multiply these two together, we would get 2x squared plus 5x plus 2, and x squared plus 4, which we get 5x cubed minus 3x squared plus 20x minus 12. And we have to multiply x squared plus 4 over 2x plus 1 to get 2x cubed. X cubed plus x squared plus 8x plus 1. So our final fraction would be 2x cubed plus x squared plus 8x plus 1 over minus x squared plus 25x minus 10 after we combine like terms between these two. If we had, I chose a slightly complex case for this one, but if we had, say, 5 over 3x cubed plus 4 over 2x, we would then get a lowest common multiple of 6x cubed with 5 times 2 plus 4 times 3x squared, which would get 6x cubed over 10 plus 8 plus 12x squared. Now on a note of finding lowest common multipliers, and LCM of A and B is equal to AB divided by the greatest common factor between A and B. So if we had 6, 10, the greatest common factor or divisor would be 2. This is the greatest number which divides both numbers. Then we would have LCM equals 60 over 2, which is 30. You can confirm this number by yourself. That is the lowest common multiple of 6 and 10. To relate this to finding the lowest common multiple between two variable expressions, if we had x squared plus 2x over x cubed, the greatest common factor is x. X divides this, x divides this, nothing bigger than x divides either. So we would get x4 plus 2x3 as the lowest common multiple between those two expressions. If the x cubed was something like x plus 3, then the greatest common divisor would be 1, since nothing shift between these two. So the lowest common multiple, if we had a fraction of 1x squared plus 2 over x plus 1 over x plus 3, the denominator would be the product of these two. By the way, LCM doesn't really apply to variables, but I'm just using it for convenience sake. LCM's mostly numbers. Now, does anyone have any questions? Otherwise, the lesson's over and you guys could leave.